Well, guess what's next? Hi, this is Craig Miller with Miller's Graphics, and we want to do a quick demo for you on the Explorer this evening. So to start off, the Explorer was written by Doug Warren. He did, in our opinion, a very excellent job on the program. Spent a lot of time working on this for us. And the purpose of the Explorer is to help you understand how the computer works, how it thinks, how the BIOS works, how the operating system works, how the GPL interpreter works. Also, it's can be used for a variety of explorations of modules and to help you perhaps debug your assembly language programs. So to start off with, this is the main screen on the Explorer. The Explorer contains basically 4 screens. It contains the main screen, it contains this options screen, it also contains the register screen, and it contains the application program screen. This is the load and run screen from the editor assembler. This is where we left off. Now, prior to starting up the demo, I loaded Tombstone City in with the Explorer, so we'll play with that in a minute here. We made a few mods to the Tombstone City game, took out some of the time delays and made it so that it wouldn't auto-start by taking the in-start off at the end of the program. So let's go back to the Explorer screen here. And at any time you can toggle between screens with whether the Explorer is running or whether it's standing still. Now basically the editor assembler has cleared off the file name. We're continuing execution of the editor assembler module at this time. In a second here the cursor will come back. Here we are. Now there are 2 ways that you could start up a program. The normal way would be to press enter at this point and go in and get the program name and type it in, or we'll stop the Explorer here, and the other way is to go ahead and find where the start address is and just set the PC, where the cursor is at right now, at that address, and Tombstone City will start up. Now the start name for the Tombstone City game is start. So here it is right here in memory. And this is the start address, A00C. So we could come back up here and type in A00C and Tombstone City will start right up. But in this case, we'll go ahead and let it go through the normal program name, which is a little easier for some people, because sometimes in the ref-def table there are a lot of other items and it may be hard to find where the name is. But before I start it back up, I want to show you a few things about the main screen here. This area up in here controls the CPU, what address it's at, what workspace it's at, etc. This is the GROM information. This controls what GROM address you're at and what the last byte was read from GROM and what the GROM status is. This section over here is the VDP control area, and this controls the current VDP address and the byte last read or written to VDP, and the VDP status. This the section on the far right-hand corner of the screen is the CPU status register broken down into binary form, so it's a little easier to see and understand. Then down at the bottom here, or in the middle of the screen rather, we have all of the workspace registers for the assembly language program, so that you can see them as they change one by one, or as the Explorer is running. You'll notice that they're dynamically updated after each and every instruction. This is also true if you are letting it run in continuous mode like this, or if you're just single stepping or executing one instruction at a time. Either way. The next section down is the VDP registers. These control where the tables are and color, screen color, etc. We'll play with these in a few minutes. The next area down is what we call our memory window. There are 3 of them. Currently it's a CPU memory window. By pressing function 1, I can toggle between that and GROM and VDP. Now you can change these. I can make this also a CPU memory window, so now I have 2 CPU memory windows and 1 GROM window. It's entirely up to you, however you want to set this up. Let's go back, put that back to VDP. And the memory windows, this points to the address. This is the first address, or which would be this byte right here. And the last item here is a D or an S for static or dynamic. When a memory window is dynamic, it follows the VDP address. Now, or the GROM address or the CPU address. You know, we're static here. If I convert this into dynamic, you'll see that on the second row here, when I bring it down, that the PC and the memory pointer contain the same value. We set it up so that it tracks on the second row, so that way you have 12 bytes previous here that you can see, previous to the actual address that it's at right now. So, the memory windows can be in any one of 4 sizes, this size and all the way up to full screen. The memory windows can be displayed in hex as it is now, or in ASCII, with a basic bias. Now, this section here isn't necessary to use basic bias on. Basic bias was put in this for looking into extended basic and basics VDP screen area. Also for looking through GROM for the basic error messages, since they have a bias added to them already. Now the last section on the Explorer screen is the next instruction to be executed. It is the disassembly or the source code of that instruction. This area can be one of 2 sizes. It can be a single line or 3 lines of instruction. And as you step or execute single instructions, everything is automatically updated. The top line always shows you what the next instruction to be executed is. So if we just turn on, let it run here. Now let's set this back to GROM and start it back up again. Now if you'll notice how fast the bottom of the screen is scrolling up as compared to how often the bytes in the GROM window move, well, it gives you a good idea on how the execution time difference between machine language and GPL code. Let's go back to this screen. Right now, the editor assembler module is waiting for a key press, so I'll go ahead and press and hold enter until the cursor disappears. Now in a few seconds, the program name prompt will come up, and at that time we'll type in the start, which is the start name for Tombstone City, and then press enter, and Tombstone City will start up after the editor assembler goes through a little bit more housekeeping here. As I said before, at any time you can trade screens so that you can see this information or see the actual program screen. So our cursor's back now. So let's go ahead and type in start. And we'll go ahead and press enter. And the editor assembler will now go through a few things. It'll clear the screen, change the screen colors, and set up a few other things. Now, what we can do, stop it here. We know from our previous look in memory here, let's get this back. That the start address was at A00C. So we could set a breakpoint up here if we want, A00C. And then the Explorer will break as soon as Tombstone City takes control. There we are. So, just by pressing any key here, we can release that condition and start it back up again. So let's see what happens on the other screen here. Now let's change the screen color border. And right now in Tombstone City, basically what's happening, if you notice the VDP address, it's loading a bunch of characters and stuff here. And in a second it'll draw the title screen for Tombstone City. So you can use the Explorer with basic or extended basic, or you can use it with assembly language programs. If you have the myARC disk controller card, or the Core Comp disk controller card, or a widget, you can load the Explorer and explore other modules. So you can look at things like Parsec or the terminal emulator if you would like, and figure out how the speech works in there, etc. Here's a title screen. I'll go ahead and press 3 now to play the game, and you'll see the screen will clear off. And then it'll draw the Tombstone City game screen. And we can play the game in slower motion. A lot of times this stuff happens so fast that you don't get a chance to actually see how how it works, or how it's drawn, what order it comes up on the screen. So it's kind of nice to be able to see the order that things happen. So the game is waiting for us at this time. So let's go ahead. I'm just going to press the fire button here, and we can move around. And at any time, you can flip back, stop it, start it back up again, execute one instruction, just trace through a certain section of the program if you'd like. Now, since you're in complete control here, it's real easy to win. You can change whatever you want around. You can actually even cheat. Oh, let's say, for example, that you were stuck up here in the corner. No place to go. Well, you can just stop the Explorer here and just make a little change in the game screen. There we are. We'll close it back up so they can't follow us through. Now, another thing you can do is have your friends over, but don't tell them you have the Explorer, since everything looks pretty normal here. And especially the ones that always get the high scores and you can never seem to get up there. Well, let's just make a minor change here. There. So, now let's pause here for a minute and let's talk about some of the other screens that are in the Explorer. The next screen up is the options screen. On this screen we have a number converter, as well as a crew base switch, which allows you to look at different crew bits. And then we have the actual options here, which are the loading of character sets, executing key scan, and colors and stuff. First, let's talk about the number converter. Once again, the number converter is also dynamic. So as you type a number in, it's automatically converted into the other two number bases, and the operation is performed, whether it's a add, subtract, multiply, divide, etc. And the result is also dynamically displayed. So let's add 5, 6, 7, and 8 to that hex. And you'll see we have an add result here now. Now, by pressing function 9 on the keyboard, you can add, subtract, multiply, divide, and, or, XOR, and not different numbers in different number bases. This crew base section allows you to look at different crew bits in the console and analyze whether they're on or off, such as this one is on. There's nothing there. This one is off. Now this is the disk controller at this point. So if we come over here and put a 1 in this section and go back to the main screen, change our memory to point into where the disk controller DSR sits, you'll see that it is on and sitting there at this time. Let's increase the size of this memory window. Oh, you'll see things here like disk, little things you recognize. This is from a car comp disk controller. The memory window allows you to scroll, as you see, up, down. You can also page up. And you can page down. You can scroll 1 byte in this direction, or you can scroll 1 byte in this direction. Another nice feature of the memory window and editor, by the way, is you can put your cursor on a given character and drag the memory window around by pressing the function and shift keys at the same time. Let's go back and turn that disk controller off. You see there's nothing here now. Now, load characters high speed and execute key scan high speed are placed here so that you can either watch how the character set is loaded byte by byte, or with it on high speed, the Explorer just executes it at full speed. The reason this was put in here is basic and extended basic reload character sets at the end of the program and after every call is executed in command mode. So after you've watched the character set load a few times, I think you'll appreciate the H option here. On the execute key scan, this is used when this is an H, we turn off debounce, which is just a delay loop. If it's an S, then debounce is allowed to go through, so you can see the complete key scan routine in the console. The other items here that are options are the colors. You can set your own screen colors, whatever you're comfortable with, whatever your monitor likes. You can set your own breakpoint color so that when a programmable breakpoint is reached, the screen color will be the one that you've selected. And the last one down here is error condition. This is in case you try to press a wrong key or input a wrong value, the Explorer screen turns red as a default, but you can set any color you'd like in here. The reason we just flash the screen, there are no beeps or honks. The Explorer won't do that. The reason for that was if you are stepping through a sound routine or something of that nature that you want to trace through, we didn't want to destroy the environment by putting a beep right in the middle of it for you, just because you pressed the wrong key. So by doing this, with just changing screen color, we preserve the environment. Now the next screen is the register screen. This is a binary breakdown, and they've been labeled, all the bits have been labeled, of various registers. This top one is the GROM status. The next one down is the VDP status. And we have this register here is V0. This sets up bitmap mode or enables external video. The next one down is V1. This tells us whether we have 4K, 16K of VDP RAM, whether or not the screen is on, whether or not VDP interrupts are allowed. This enables text mode, this enables multicolor mode, and this changes the size and magnification of the sprites. Now the next VDP registers, 2 through 7, well actually 2 through 6, control the table locations, where the screen image is, where the color table is. And as you change these values, you'll notice that on the far right hand side of the screen, we automatically multiply them out for you so that you know exactly where in VDP RAM the table is. You don't have to calculate it out yourself. And again, this can be changed in either binary form or in hex form. That's true for all of these. The last one, V7, sets up the screen color, text in screen colors. And as we left off here, Tombstone City has its screen color set at red. If we wanted to, we could change the VDP register on this screen without going to the other one, or we could go to the other screen to change your choice. So let's make it, dark blue. Let's see how that looks. Not too good. So let's go back to red here. Now another item in the Explorer is, let's click down here into GROM, make this a little bit larger, and let's search. It has a search option in it. We could search through GROM, any address range that we want. So let's search through basic GROM. And let's search for error. See what we can find. What? No errors in basic? But you know there's errors in basic. So what the problem here is all the error statements are with a basic bias in them. So let's turn on basic bias and now search for error. There's the first occurrence. And by just pressing enter, you can find each occurrence of it. And that's the last one. Now there are also some error messages in, oops. In the editor assembler GROM. Let's go back into search here. And let's search through the editor assembler section. And in this case, there are error messages that are with a basic bias. And then there are also some without a basic bias. So the ones with the basic bias are used by BASIC. The other ones are used by the editor assembler module. Yep, still there. Now at any time, let's say you've been running Tombstone City here, and at any time you can halt this and go into the power-up routine if you would like, or hop right back into the editor assembler module. Let's do that. Let's stop this here. And start the editor assembler module up. Here, I'll trade screens and start it up. There we are. There we go. So I'll just go ahead and there may be one thing that needs to be changed here though. No. Now when I press enter, it will clear off the screen and generate the editor assembler menu again for us. And at that time you can make another selection or press function 9 to go back through the power-up routine or wherever you'd like to go. So let's press function back when it comes up. We'll go through the power-up routine then. So I believe it's looking for a key press at this time. So we'll go ahead and press function 9. And we've started the power-up routine. Now on power-up, let me set this up here. On power-up, the power-up routine turns off the screen. This is V1. If we go over to this register here, you'll see that the screen bit's been turned off. So we'll go ahead and turn that on. And now we can come back and take a look. There may or may not be anything on the screen at this time. Well, there's garbage on there. So let's go ahead and start that up. That'll turn this screen bit off 4 times before it leaves it alone. And at this point, I could tell by the GROM address after playing with this for quite some time that it won't turn off the screen anymore on us. So let's see what's on the screen. Now, at this time in the power-up routine, the power-up routine goes through and clears out the first 4K of VDP RAM. Now I'll pause this. I'll pause the videotape and let it go ahead and clear that out so you don't have to sit here waiting for it. It takes about a minute and a half to clear this out. So, well, it's finished clearing out VDP RAM now. And what it's going to do next is load the color table, and then it'll load the character set. So the character set load in the powerup routine does not use the built-in subroutine, so those do not execute at high speed. That's the only one that we've run into, other than like the TE2 also does the same thing. It loads its own character set. So what we're going to do at this time, I'm going to put some characters on the screen. You won't be able to see them yet because it's cleared out VDP RAM. They don't have any definitions yet. So we'll go into the VDP screen image area for powerup routine, which is at 0. And we'll put it in ASCII mode, and we'll put in some characters. Okay. See, they're not there now, but I'll go ahead and start up the Explorer. It'll finish loading the color table, and then it will load up the character sets. Here they come. After the character set's fully loaded, it will clear off the screen, and then it'll start building the title screen with the color bars. Now it builds 3 rows of these color bars. That's how the title screen builds. You normally can't see this because they have the screen turned off. And it happens much faster. After the 3 rows are built, it brings out the TI logo and all the other letters that come up on the screen. Now, since you're in complete control, again, you can stop it at any time and go anywhere you want, back up some instructions, provided things are set up properly, and look at another area, see how it executes. So this time the title screen's fully built. Now we can go in and change it if we'd like. So we'll make a minor modification to this screen. Now we'll move that over a little bit. There we are. Let's make a couple other little changes here. There we are. Now, before we hop into BASIC, let's play around with the registers a little bit, the couple of EDP registers, and let's see what the screen looks like in bitmap mode and text mode, multicolor mode, etc. Let's see here. Now, to enable bitmap mode, just write a 2 to this register. You'll see when we go to the register screen here that the bit is for bitmap mode is turned on here. So now let's go back to the title screen, see what it looks like. I'm sure we've seen this before. Kind of looks like lockup. Now, another condition that we've all seen is this one, video out of sync. The least significant bit turned on. So if we go here, you'll see the external video enable bit is turned on, and when that's turned on, the VDP chip in our console is trying to sync itself with an external video chip. There isn't one, so the screen's out of sync. Let's turn that off, get the screen back to normal. Alright, now let's take a look at this in text mode. Now, let's see, F7, that would be, let's make it F4 in text mode. That would be white letters on a dark blue background. Now, title screen characters in text mode don't work out too well. Set that back. Now let's look at it in multicolor mode. Okay. Back to normal. And before we start the Explorer back up, let's do this. Let's hop directly into BASIC from here. We could let it continue to run and go through the menus in the title screen, and then make a selection from there when we go ahead and pick BASIC when the menu comes up, or pick a module that's plugged into the port, etc. But in this case, let's I'm going to show you how to directly hop into say BASIC, and you can do this just about any time that you want when you're running the Explorer. So first thing let's do, let's find the beginning of TI BASIC in GROM. So we'll put our memory window on GROM, and we'll leave it in ASCII mode, and we'll set us up to search through BASIC GROM. By the way, all of this stuff is documented in the manual also. You don't have to remember this. I'm not going to take a test at the end of this demo. So here's where the word TI BASIC comes from. This is for the menu. Now if we hop out of the search function and hop into the memory window and 1, 2, 3 and go into hex mode, this 216F is the start address for BASIC. The next byte here says 08. That's 8 characters. 1, 2, 3, 4, 5, 6, 7, and 8. And that makes up the menu. But the first two, let's put that back. These 2 bytes, or word, make up the start address for BASIC. And that's the GROM start address. So we'll come up here to the GROM area, put in the start address, 216F. And make sure our workspace is at 83E0, that's the GPL workspace. 006A is where we want to start the GPL interpreter. And we'll start it up. Let's go back to this screen here. BASIC will clear the screen. It hasn't set its VDP registers yet or loaded its character set, so it's clearing the screen with a character that was defined as green. There we are. Now, while BASIC's scrolling the screen, it's going to scroll the screen up one line and then it'll bring the cursor out. But while that's happening, let me talk about the manual for a second. The manual that comes with the Explorer is approximately 112 pages in size. It contains a complete documentation on all of the things on all of the Explorer screens, all of the different fields, any place the cursor can move to. Everything's been documented. That entails a good portion of the front of the manual. Also in the front of the manual is We talk about the different files that are on the disk. There's a extended basic loader, editor assembler mini-mem type loader, or other load and run type loaders on there. And it is compatible with the TI disk controller card, the Core Comp disk controller card, and the MyArc disk controller card. The front of the manual also talks about all of the function and control keys that are programmed for the Explorer. And the Explorer does come with a function key overlay strip to lay on top of your computer so that you don't have to keep referencing the manual or anything. It makes it quite a bit easier to use. Then we take you through a quick startup just to get you off and running real quick. And then we get into documenting the actual Explorer's screens, all of the different areas again. Then at the end of that section, just about right in the middle of the manual, we discuss how the interrupt routine works. The Explorer will execute interrupts, and it will execute user interrupt-driven routines also. You can do some routines for basic or extended basic that are interrupt-driven and see exactly how they're working within those environments or within your own assembly language environment. Then we have a section that we call explorations, and we take you through, we step you through the key scan routine, and we walk you through the power-up, executing the power-up routine, and we talk about things along the way, which I did not do when we just went through the power-up routine. We just went right into it. Then we tell you how to execute a basic call and walk through it, and talk about different things as it's happening and what the computer's doing, etc. And the same thing with an extended basic call. Then we talk about how to execute other assembly language programs, such as we did earlier in the demo with Tombstone City. And then we talk about direct execution of modules, in case you have a loader that allows you to have any module you want plugged in the port and load the program, such as the MyArc call LR or the disk manager, the Core Comp disk manager's load and run option. Or if you have a widget, then you can explore any module that you would like. And in the back of the manual, we have a number of modules listed with their start addresses and what VDP registers they would like. And we call this a worksheet, and there's space in there for you to write whatever you would like alongside if you find your address slightly different, but it's usually rare on a module. Then on the very last page is a complete worksheet for the same thing, so that you can write other modules down and keep them referenced in the manual. And we also have a breakpoint worksheet in the back of the manual that allows you to write down different breakpoints that you've decided that you want. These are the programmable breakpoints we're talking about. Also in the back of the manual is, in the appendixes, is complete memory maps. Some of them we've run in the Smart Programmer newsletter. Some of them we have not. We've included in the manual a complete Council ROM memory map with all the vectors called out for the GPL interpreter and many of the other items that are in Council ROM. And we also have all of Scratchpad RAM, all 256 bytes of Scratchpad RAM memory map for extended basics use. So you can see what all the addresses do there. And also included we have a Council CrewBit map. And we talk about how the keyboard is mapped out in CrewBits with its 8x8 matrix and what some of the other CrewBits do in the Council. So now that we're back to basic here, Explorer's still running. We can type in anything that we would like to type in at this time. You can type in a call, you can type in open, you can type in a line number and type in a line and watch how it's how BASIC handles that, how it crunches it, moves it down into memory, where it stores it. You can type in A equals 2 and find out how it assigns a variable, or you can type print A and find out how it finds a variable and prints it out on the screen and converts it. So you can learn an awful lot about how BASIC, extended BASIC, etc. work. So let's go ahead and execute a small basic call, or at least start one up anyway. Oh, we'll type in, say call screen at this time. Let's make it red. This is one of the examples in the manual, by the way. Now, what BASIC's doing right now is it's parsing and crunching this line. By that we mean that it is finding out what words you've typed in. And first it will find the word call, and then it will crunch it into its token code, and then it will crunch screen in the 7 value. After it's done crunching, it scrolls the screen up one line, and then it begins execution of it. Now, if you'd like to trace through just the screen portion, you can. Using the search function in the Explorer, you can stop the Explorer and excuse me, turn on the search function. Again, search through basics space ASCII SCREEN. Let it find where screen is. There it is. And we hop down into the memory window, and again 1, 2, 3. So the start address for screen is at 37BF in this console. So we can set that breakpoint here, 37BF. We'll let it run. Now, just before it executes screen, the Explorer will break, and it'll come up in its breakpoint colors. If you want to see what it's doing right now, it is, if we go into VDP RAM, and set it on dynamic here. See that it has the word screen here in its crunch buffer. Let's hop into the crunch buffer for a second. This is part of the color table here. 9D is the token code for call, so it's crunched call. This C8 means that there is an unquoted string coming, and right now it has 5 characters. It knows it's 5 in length, but actually it's a little longer than that. But as it adds each character to the crunch buffer, it changes this value. So let it crunch that a little bit more. See, it's changed that value now to 6. See here? And we have the full word screen in there. Now the next thing that's going to happen is it's going to go ahead and crunch up the open parentheses and then tell us that we have another unquoted string for the 7, and then the close parentheses. And then after that it will go ahead and scroll up the screen when it's done crunching this. Well, let's see what we're doing here. Let's take a quick peek. Looks like we're grabbing the end of the line now. I believe it's all there now. There it is. So that's how it crunches call screen. Here's again unquoted string, length of 1, character is a 7 for our color, and this is a close parenthesis, B6. Well, let's let it run. Scroll up the screen. Now when BASIC scrolls the screen, it moves 1 byte from one row to the previous row. One byte at a time all the way across the row. It's closing up this crunch. Here we go. If you look at the VDP address, you'll see that it hops on a plus hex 20 boundaries, which is 1 row. Now you can't see anything happening because it's scrolling the top of the screen, and so it's just replacing space characters with space characters at the moment. But in a second it'll get down to where TI Basic Ready is, and you'll see it come up, and then it'll clean off that line and then scroll up call screen. The extended basic scroll works slightly different. It's a little bit faster. Now that it's done this, it's going to go out and search through the DSR space and then through GROM to find the occurrence of the word screen, so that it can get the start address for the screen and can continue execution from there. Well, it's found it in GROM and has reached that point. It's now getting ready to execute the word screen. So let's clear this breakpoint. I'll just put F's in here. That'll clear it out. Then we'll go back to this and let it run. second, you'll see the borders will change back to normal. Now BASIC's going through its done routine, reloads the character set and resets the keyboard, sets up all the colors, resets the screen colors and character colors, then scrolls the screen up again and brings the cursor back out. That's basically it. We won't let it run all the way through because, yeah. There we are, back to where we were. So let's just stop it right here. And that's basically what I have to show you for right now on the Explorer. As you can see, it executes in many different environments, and it's quite a learning tool, especially since you can continuously execute or single execute, and because you can flip back and forth between the actual program screen and the Explorer screen. So it's kind of like having the Explorer run in the background underneath your program, and you can bring it up at any time. Naturally, it is, as you've seen, it does run slower because it is being interpretively executed at this time, but the wealth of knowledge that this thing returns because of that is tremendous. There isn't another utility on the market like it. So we hope you've enjoyed this demonstration of the Explorer. Now I'd like to close this demonstration out by letting you know the Explorer is available through many of the local dealers, and some of the users groups also carry it, or it's available directly through us. The retail price on it is $24.95. That includes the manual and function key strip and complete package. And if you're going to order direct from us, there is a $2 shipping and handling charge on it. So once again, thank you for your time, and I hope you've enjoyed this.